So hi guys, here we will be discussing about convolution with tiling. It includes 2D convolution with tiling, 1D convolution without tiling, and 1D convolution with tiling. So going to the 2D convolution with tiling. Here, tiling is the concept of ensuring hollow pixels, not only the main pixels, but also ensuring to include hollow pixels during the convolution layer. Okay. So here mask width. This mask width and shaded size is nothing but defining the size of the convolution mask and the memory needed to allocate the convolution mask in the memory. Here in this line, we are defining the size of the memory which is needed to allocate the convolution mask in the GPU memory. Here we will be defining the convolution mask. So here coming to the code, this mask width is nothing but defining the size of the convolution mask. Here in this line, define shared size, it is nothing but defining the size of the memory which is needed to allocate the convolution mask in the GPU memory. So it is nothing but the size of memory needed to store the convolution mask. So it is defining the convolution mask in the GPU memory. It is just like allocating it. Yeah. So here this block it is about kernel block. Here we will be initializing two threads, thread X and thread Y, and these I and J are the global coordinates of the thread, the initialized threads. Once we have initialized the threads, we are going to allocated initialize a 2D matrix in the GPU memory so that it can store the pixel values. So once we have generated the threads and we have also initialized a matrix to store the pixel values, we will be loading the pixel values into the matrix we have generated. So this is the formula needed to load the pixel values into the matrix. So once we have loaded the pixels into the matrix, we will be doing tiling. These tiling include loading hollow pixels into the convolution. So in this tiling concept, we will be doing tiling on all sides of the image. That includes left side, right side, top, bottom. So coming to this hollow function, these if conditions are making sure that the convolution indexes are in the image boundaries itself. So this here in this if statement, we will be checking if the index is in the image boundary, we will be initializing the hollow pixels to the matrix. If the indexes are out of range, that is, those are out of the image boundary, we will be initiating these pixel values to 0. So the same process is done with the, so this is processing on the left side of the halo. We'll be doing this on the right side, top side, bottom side. Once this all sides are done, we will be doing synchronizing the threads. These include synchronization thread means make sure the threads all go in a same pace. That's it. Yeah. So after this tiling process is done, here we will do the main convolution part. This convolution part include this formula. This is the equation formula for convolution compilation. Okay. These if conditions for all statements make sure that indexes are in the image boundary. Once the convolution part is done, we will be doing the check CUDA error. In this function, we will be checking the any errors are in the compilation. These errors include whether compilation error, runtime error, allocating the memory error, whatever it is. So coming to the main block, here we will be taking the input of the values. So this all comes under taking input of the values. Here we will be allocating memory. This host to device is nothing but copying the input data from CPU memory to GPU memory. That's it. Yeah, here this dim block and dim grid. These are the statements where it initializes the block of the threads, that is 32 by 32 a block of threads. Once the block is initialized, here it makes sure that this dim grid block makes sure that the grid layer is on the image fully. The grid layer is on the image fully. So here the function is called. We will check whether there is an error or not. Here we will synchronize those CUDA threads, and once the convolution and all the operations are done, the output that is which is in GPU memory is copied to the CPU memory. So once this all done, the output matrix is printed. Since we have initialized the memory here, we will be set freeing the memory. This comes in 2D convolution with tiling. So coming to the 1D convolution with tailing, it only changes. It is similar to the 2D convolution with tailing, but it only changes the dimensions itself. So here we'll be taking the convolution mask to only one dimension. The same goes to the threads. We'll be only initializing one thread with only one global coordinate, and we will be also initiating the memory for the to store the threads. Here we will be loading the pixels into the memory. So since it is a 1D convolution layer, it is a 1D convolution with tiling, we will be only doing left side halo and right side halo. It doesn't contain, we can't do top halo and bottom halo since it is a 1D dimension. So all the operations are same. We will be using here synchronization of threads. Here we will be doing a compilation of the convolution part, and it is the same as the check code error. In this main block, we will be defining the A matrix, that is input matrix, and C is the output matrix. We'll be taking input values, and here we will be initiating the memory. In this CUDA hosted device, we will be it's same as the 2D convolution tiling. The CPU memory is the data which is in CPU memory copied to GPU memory, which is same. Here we will be, since it is a 1D dimension, we only use that two. Since it is not 2D, we will only be using one dimension. So the dim grid block makes sure the grid layer is all over the image. So the all is same. It is very similar to the 2D convolution with tailing, but the only difference is it is only one dimension. So once the convolution with tailing part is done, we will be doing only 1D convolution. It doesn't include tiling. So since it doesn't include tiling, there is no need of ensuring the halo pixels to load into the memory. So we will be defining the size of the convolution mask. We will be defining the size of the memory needed for the allocation of convolution mask. Here we will be, it is the kernel block. Here, so it is the one dimension will be generated one thread with one global coordinate. So as the same it is here, we will be loading the data into the memory matrix. I mean the matrix we have initiated in the memory. So once the convolution part is done, since we are not doing tiling, there is no halo part. Okay, the convolution part is over, so the component is there. So we will be checking the errors, same as every code. Here we will be A is input matrix, C is output matrix. We will be taking input values. Here we will be initiating memory. Here the data is copied from CPU memory to GPU memory. Yeah, since it is a 1D dimension, we are also needing only 1D. I mean, there is no need of taking two dimensions. Make sure the grid is all over the image here. Yeah, and this one function call. Yeah, device to what means the value which is operated in the GPU memory is copied to CPU memory. That's it. Yeah, once we have done these operations, we will be setting free. These are the print statements to print the output. So yeah, this is convolution with tiling and convolution without tiling in 2D and 1D.